Hello everybody, welcome into another lesson. So today we are starting the analytic geometry unit, where today's lesson is going to largely be a review from Algebra 1 plus some applications of the distance formula, the midpoint formula, as well as slope. We're going to talk about the slope also. And then the subsequent lessons, we're going to get into conic sections, which we've never done before. But now that we're in Algebra 2, we're definitely going to be able to do those. So let's start out here. So a lot of you by now have probably seen this formula. If you want to find the distance between 2 points in the coordinate plane, it's the square root of the quantity of the second x-coordinate minus the first x-coordinate, that quantity to the second power, plus the quantity of the second y-coordinate minus the first y-coordinate, that quantity to the second power, and the square root of all that. And then to find the midpoint of two coordinates in the coordinate plane, you take the sum of your two x-coordinates, divide that by 2, and then it's going to also be the sum of your two y-coordinates, divide that by 2, and then you'll get the coordinate for the midpoint of those 2 points. So let's say I'm given the points 0, 0, and 3, 4, right? I want to find... First, we're going to find the distance between 0, 0, and 3, 4. So I'm just going to plot those so we can look at this in real time here. 0, 0, 3, 4. We want to find the distance from 0, 0 to 3, 4. Basically the length of that segment. You could think of the distance as the length of that segment. So to find my distance, I'm going to take the square root of my second x-coordinate, which is 3, minus my first x-coordinate, which is 0, raise that to the second power, plus my second y-coordinate, which is 4, minus my first y-coordinate, which is 0. And then I'm going to simplify. So 3 minus 0 is just 3. I would get the square root of 3 squared plus 4 squared, which would give me the square root of 9 plus 16, which equals the square root of 25, which means I have a distance of 5 units. So the distance between the 2 points 0, 0 and 3, 4 would be 5 units. So the length of this line segment is 5 units. Now what about the midpoint? In this case, to find the midpoint, I'm going to take my first x-coordinate of 0 plus my second x-coordinate of 3, divide that by 2, then take my first y-coordinate of 0 plus my second y-coordinate of 4, divide that by 2. Well, that would simplify into 3 over 2, and then 4 over 2, which when we simplify the final time would make my midpoint at 3/2, 2. So the midpoint of 0, 0, 3, 4 is at 3/2, 2, which 3/2, 2 is going to be 1.5, 2. So that's going to be right here. And there's my midpoint at 3/2, 2, right there. So that's basically all we're doing to start with. I'll do 2 more points and then we'll move on to some applications. All right, what if, let's see, this time we got the points 9, -2, as well as 3, 6. So first we are going to find the distance between the points 9, -2, and 3, 6. So 9's here, -2's down there. Now what about where's 3, 6? There's 3, 6. And just to put this into perspective, I'm going to draw a line between the 2 points. So I'm finding the distance between the 2 points, and basically, in a graphical sense, I'm finding the length of this line segment here between the 2 points. So let's find the distance here. So let's input everything into the formula. That'll be the square root of our x2, which is 3, minus our x1, which is 9, all that raised to the second power, plus our y2, which is 6, minus our y1, which is negative 2. This would really become 6 plus 2 squared. So this would turn into the square root of negative 6 to the second power, plus 8 to the second power. So this would become the square root of 36 plus 64, which would end up giving me the square root of 100 for a distance of 10 units. So the distance between 9, negative 2 and 3, 6 is going to be 10 units, or the length of this line segment is 10 units. Now what about the midpoint of those two segments? So let's find the midpoint. The midpoint would of course be my x1 of 9 plus my x2 of 3 divided by 2, and then my y1 of negative 2 plus my y2 of 6 divided by 2. So this would simplify into 12 over 2, 4 over 2, which for the final simplification would give me the coordinate 6, 2. So 6, 2 is actually the midpoint between 9, negative 2 and 3, 6. 6, 2 would be my midpoint. So let's plot that here. And right about there, I didn't draw it the best, but there's my midpoint of the segment right there, is going to be at 6, 2. And I got one more. Now, if in general, if you're finding the distance and midpoint of two coordinates, generally you don't have to graph it. I'm only graphing to show you what's going on. And plus, we're going to have a couple of applications today that do involve finding, graphing. So let's do one more here. All right, what about the points negative 2, 10, as well as, oh, that's a big distance. That's going to be big. And then 10, negative 2. So we're going to find the distance between negative 2, 10 and 10, negative 2. So let's plot those. Negative 2, 10 is all the way up here. 10, negative 2 is all the way down here. So I plotted them. I'm going to graphically show you what is actually going on with this here. So basically we need to find the length of this segment right here, which connects those 2 points. So let's go ahead and apply our distance formula. So the square root of your x2, which is 10, minus your x1, which is negative 2. Well, minus negative 2 turns into plus 2, plus your y2, which is negative 2, minus your y1, which is 10, all that squared. So that's going to equal, of course, now the square root of 12 squared plus negative 12 squared, which would end up giving me the square root of 144 plus 144, which would be equal to the square root of 288, which is best broken down into the square root of 144 times the square root of 2, which means my distance is 12 times the square root of 2 units. So the distance between these 2 points would be 12 times the square root of 2 units. Okay, now let's find the midpoint. So to find the midpoint, I'm going to take my x1 coordinate of -2 plus my x2 coordinate of 10, divide that by 2, then take my y1 coordinate of 10 plus my y2 coordinate of -2, so 10 minus 2 divided by 2. Well, this would all simplify into 8 over 2 and 8 over 2, which would basically put my midpoint at 4, 4. So the midpoint of these two segments would be at the point 4, 4. So let me plot that. I really butchered the line, but 4, 4, so really I should have drew it down lower, but 4, 4 is technically the midpoint. I was kind of drawing it free-handed, but 4, 4 is mathematically correct. I just drew this wrong, but so yeah, 4, 4 is the midpoint. Now, we've seen how to do the distance and midpoint between two points. Now, what if we're going to switch this a bit here? We're going to solve for some missing coordinates between the points 0, 1 and then x4. They even tell us that the distance equals the square root of 34 units. So now we're going to use the distance formula to find the missing x-coordinate of the second point. So you have the points 0, 1, x4. The distance equals the square root of 34. So what would be the missing point there? Well, I think it's helpful to plot 0, 1, just so I can graphically show you what's going on. Alright, now, the distance here. So we know the distance formula, of course, is the square root of our x2, which would be x minus the 0 squared plus that y2 of 4 minus 1 squared. That's our distance formula. That equals the square root of 34, right? Well, this would simplify into the square root of x squared plus 3 squared is equal to the square root of 34, which means the square root of x squared plus 9 is equal to the square root of 34. Well, of course, in order to solve for x, we need to get rid of the square roots, so this would become x squared plus 9 equals 34 when you square both sides. So x squared would equal 25. That means that x could equal both plus and minus 5. So your missing points would end up being at either plus or minus 5, 4. So either of those points are going to be equidistant from 0, 1. Either of those points will be the square root of 34 units from 0, 1. So this is where you could actually have two answers in theory because of the quadratics. Let's do two more like this. All right. So this time I have the points 1, 3. I have 1, 3 and negative 6y. So this time I got to solve for y. The distance between the 2 points is the square root of 74. Alright, so I have the coordinates 1, 3, and then negative 6y. We don't know that y coordinate, but the distance is the square root of 74. I'm going to plot 1, 3 just so I can graphically represent what's going on. Now, let's input everything into our distance formula and set that equal to the square root of 74. So this is going to mean our distance formula is our x2, which is negative 6, minus our x1 of 1, that's all squared, plus my y2 of y, minus my y1 of 3, all raised to the second power. The square root of all that equals the square root of 74. Alright, so now this would simplify into the square root of negative 7 squared plus y minus 3 squared is equal to the square root of 74. Which really means then the square root of 49 plus y minus 3 squared is equal to the square root of 74. So now let's go ahead here and square both sides and get rid of the square root. This would become 49 plus that y minus 3 squared equals 74. And then if we do the subtraction, you would end up getting y minus 3 squared equals 25. Now we got a quadratic. We take the square root of both sides. You get y minus 3 equals both plus and minus 5. So y equals 3 plus and minus 5. That means your two solutions for y are either going to be negative 2 or positive 8. So you have two solutions for y. They can either be negative 2 or positive 8. So let's plot those. So if we get negative 6, 3, 4, 5, 6, negative 2. So let's connect these 2 points right here. Or we could get negative 6, 8. 6, 7, 8. You see that both points are equidistant with a distance of the square root of 74 units from the coordinate of 1, 3. And I got one more like this, then we're going to move on again to another type of example. All right. We have the point x negative 10 negative 8, is that negative 4? Negative 8 positive 4, excuse me. Okay. So we have a coordinate x negative 10 where we don't know what x is, and then a coordinate of negative 8, 4 with a distance of 7 times the square root of 5. So the distance is 7 times the square root of 5. Well, let's plot negative 8, 4. 2, 3, 4. There's negative 8, 4 right there. So I know one of these x's is definitely going to be off the chart. It's going to be outside of the graph, but that's okay. So let's go ahead, set up our distance formula with these points, and then we'll set that equal to 7 times the square root of 5. Okay, so take your distance formula, so the square root of the x2, which is negative 8, minus your x1, which is x, raise that to the second power, plus your y2, which is going to be 4, minus your y1, which is negative 10. This turns into 4 plus 10 squared equals 7 times the square root of 5. Well, this is going to then turn into the square root of still negative 8 minus x to the second power plus 14 squared equals 7 times the square root of 5. So this becomes the square root of negative 8 minus x plus 196 equals 7 times the square root of 5. All right, let's go ahead here now, square both sides to get rid of your square roots. So this would become negative 8 minus x plus 196 equals what? So 7 times the square root of 5 squared, that's 49 times 5, that's going to be 250. Or 245, excuse me. You'll get 245. Well, this would simplify then into... Whoops, I forgot to square that. No wonder. Never mind, this won't... I forgot to keep that squared. No wonder I'm getting it wrong. So this would be negative 8 minus x squared would end up equaling 149. Well, this is going to be fun. Does the square root of 149 simplify into anything? That's what I'd like to find out. No, it doesn't. No, it doesn't. So this would have to mean then that negative 8 minus x equals plus and minus the square root of 149. Which would then have to mean that negative x equals 8 plus and minus the square root of 149. Which would have to mean that x equals negative 8 plus and minus the square root of 149. So you got two answers for x. You get negative 8 plus and minus the square root of 149. Well, minus the square root of 149 is going to be way off the graph. But what about the square root of 149? Let's take that. That would give you, let's see, that minus 8, that would put you at about 4.21. So about here all the way down to negative 10. So that's the point they would be referring to. And then the other one, as you see, would end up going the other way off the chart. But that's basically how you find missing coordinates using the distance formula. All right, now we're going to talk about classifying triangles. We can use the distance formula to classify triangles. We're going to do 3 exercises of that. So let's see, we have the points 2, 0. So let's start out plotting 2, 0. What other points do we have? 0, 8, which is going to be all the way up here. Let's connect those points. Then what's the third point? Negative 2, 0. So negative 2, 0 is right here. All right. So we're going to classify these triangles as equilateral, isosceles, it actually has SC, isosceles, or scalene. So our job here, we have 3 coordinates which form a triangle here in the coordinate plane. It's our job to determine, is the triangle equilateral, which means all 3 sides are the same length? Is it isosceles, which means two of the sides are equal to each other? Or is it scalene, which means none of the sides are equal to each other? Well, here's what we're going to do. We're going to use the distance formula on each side. So let's find the distance between negative 2, 0 and 0, 8, right? So let's go between negative 2, 0 and 0, 8. So let's take the negative 2, that x2 coordinate, minus our x1 of 0 squared, plus our y2 of 0 minus the 8 squared, which is going to then equal, of course, the square root of negative 2 squared plus negative 8 squared, which would equal the square root of 4 plus 64, which would equal the square root of 68, which breaks down into the square root of 4 times 17, which would give you a distance of 2 times the square root of 17. So the length between negative 2, 0 and 0, 8 right here is going to be 2 times the square root of 17. So I'm going to take that distance and write it according to its corresponding side. Now, let's find the distance between 2, 0 and 0, 8. So let's go ahead and do that. What about, okay, so let's do 2, 0 and 0, 8. So the distance, of course, is the square root of your x2, which would be 0 minus your 2 squared plus then your y2 of 8 minus your y1 of 0 squared. So that's going to give you the square root of negative 2 squared plus 8 squared, which would give you the square root of 4 plus 64, which would equal the square root of 68, which again breaks down into 2 times the square root of 17. So between 2, 0 and 0, 8, the distance also happens to be 2 times the square root of 17. Well, we have 2 equal sides so far, so it's definitely isosceles, but is this equilateral? We know it's not scalene because we have 2 equal sides. It's at least isosceles, but what about between negative 2, 0 and 2, 0? So let's find the distance of those 2 points. So take your x2 of negative 2 minus your x1 of 2, square that. plus your y2 of 0 minus your y1 of 0, raise that to the second power. Well, okay, negative 2 minus 2, that's negative 4 squared. That's 0 minus 0, don't even bother with that. This turns into the square root of 16, which equals the square root of 4, which equals 2. So the distance between negative 2, 0 and 2, 0 is 2. I think I need some new red markers. Let me grab those real quick. Or I'll just use a green one in the future. So we can certainly say then, because we have two equal sides, this is an isosceles triangle. So we ended up with an isosceles triangle because two of the sides were equal to each other. All right, I'm going to do two more like this, and then there's one more application we're going to do. Well, I'm going to leave that classify up because that's exactly what I want to do. All right, what points can we come up with now? All right, so we have the points 4, 1. So why don't we start plotting them here then? Here's 4, 1. What about 1, negative 2? All right, so here's 1, negative 2. And then we're also, actually, let's go ahead and start connecting. What's the third point? 6, negative 4. The third point's going to be 5, 6. There's 6, negative 4 down there. Alright, so there's our triangle. It's going to be up to us to classify. You know what? Let me label the coordinates here too. Maybe that would help if I label coordinates. 1, negative 2, and then here is 6, negative 4. Alright, so there's my coordinates for this triangle. Is it an equilateral triangle, isosceles, or is it scalene? Let's find out. So let's take the first distance. Let's go between 4, 1 and 1, negative 2. So let's see. That's going to be, of course, my x2 of 1 minus my x1 of 4. That quantity squared plus my y2 of negative 2 minus my y1 of 1, that all squared. So this would become the square root of negative 3 squared plus another negative 3 squared, which would become the square root of 9 plus 9. Square root of 9 plus 9. I don't know why I have another square root there. Which would equal the square root of 18, which equals the square root of 9 times the square root of 2, which would make the distance 3 times the square root of 2. So the length between 4, 1 and negative 1, 2 is going to be 3 times the square root of 2. All right, so we got one side. Now what about the other two? Okay, what about between 1, negative 2 and 6, negative 4? So the distance here, let's see. So let's take our x2 of 6 minus our x1 of 1, square that, plus our y2 of negative 4 minus our y1 of negative 2, which would actually turn into plus 2, that quantity squared. That's going to equal, of course, then the square root of 5 squared plus negative 2 squared, which would give you the square root of 25 plus 4, which gives you the square root of 29 with no further way to reduce it. There is no further way to reduce this. So this side here has a length of the square root of 29. Now what about between 4, 1 and 6, negative 4? We still have to find the length of that side. Alright, so let's find the length there. So our x2 is going to be 6 minus our x1, which is 4, that quantity squared, plus our y2 of negative 4 minus our y1 of 1, that quantity squared, which would actually equal the square root of 2 squared plus negative 5 squared, which would be the square root of 4 plus 25. Well, what do you know? We have the square root of 29. So this side also has a length of the square root of 29. So you have two sides with the same length. That means, therefore, this is also isosceles. We have an isosceles triangle since two of the sides have the same length. Let me see if I can find anything else as far as another type of triangle. All right. I have a feeling about this one. So what about, let's see, we have the point 1, 9. So let's plot 1, 9. That's going to be all the way up here. What about then we have negative 4, 2. We have the point negative 4, 2. So here's negative 4, 2. So let's plot that, and then I have the point 4, 2. All right, so let's label these points here. I got 1, 9, negative 4, 2, then I have 4, 2 right here. We have to determine, is this triangle equilateral, isosceles, or scalene? Well, let's find out. Let's start doing the distance formulas. So let's go between 1, 9 and negative 4, 2. So my x2 is going to be 1 minus my x1 of negative 4. So that'd actually be 1 plus 4, that quantity squared, plus my y2 of 9 minus my y1 of 2, that quantity squared. So that's going to then equal, of course, that would be 5, square root of 5 squared plus 7 squared, which would give me the square root of 25 plus 49, which just gives me the square root of 74 with no further way to reduce that. So I'm going to end up here with the square root of 74. for the length of this side. I got that right? Okay. Oh yeah, let me write the other third point up top here so I have it to reference. Alright. Now let's find the length between 1, 9 and positive 4, 2. So let's go between 1, 9 and positive 4, 2. So the distance equals the square root of, now your x2 would be 4 minus your x1 of 1, that quantity squared, plus your y2 of 2 minus your y1 of 9, that quantity squared. That, of course, would equal the square root of 3 squared plus negative 7 squared, which would equal the square root of 9 plus 49, which would equal the square root of 58, in which there's no way to break that down. So this side here has a length of the square root of 58, and then we need to find the length between negative 4, 2 and positive 4, 2. So let's go ahead and find that. Alright, so distance, let's see, our x2 is going to be positive 4 minus our x1 of negative 4. So 4 minus negative 4, well that's 4 plus 4, that quantity squared, plus then our y2 of 2 minus our y1 of 2, that quantity squared. So this is going to simplify into the square root of 8 squared plus 0 squared, which would really be the square root of 64, which equals 8. So the distance between negative 4, 2 and 4, 2 is just 8 units. So notice all three of these sides have different lengths. None of them are equal. So what does that mean? We actually have a scalene triangle. So this particular triangle is scalene because none of the three sides are equal to each other. So that's how you can use coordinate geometry to find the lengths of sides of triangles and classify them. Now I got one more application here. One more. I'm going to bring this up here. Remember the slope of a line. The slope equals y2 minus y1 over x2 minus x1. That should look familiar to everybody. Slope of a line is y2 minus y1 over x2 minus x1. So where are we going with this? So write the equation of the perpendicular, haven't seen that symbol in a while, perpendicular bisector of the line segment joining the points. So let's get the points here, of course. Zero, 0, and -8, -10. Alright, so we need to write the equation of the perpendicular bisector of the line segment joining the points 0, 0, negative 8, 10. Let's plot our points first. Here's 0, 0, negative 8, negative 10, excuse me. Here's negative 8, negative 10. There we go. We need to find the perpendicular bisector of this line segment right here. So if we recall from geometry, what is a perpendicular bisector? Well, the bisect part means it's a line segment that intersects this line right in the middle of the line. It intersects it right in the middle. So what does that mean then? In the middle of the line means we have to find the midpoint of this line segment, don't we? So let's find the midpoint, okay? Midpoint, that's going to be your x1 of 0 plus your x2 of negative 8, so 0 minus 8 over 2. And then your y1 of 0 plus your y2 of negative 10, so 0 minus 10 over 2. Which is going to equal negative 8 over 2, negative 10 over 2, which means your midpoint is going to end up being negative 4, negative 5. So your midpoint's negative 4, negative 5. Let's go ahead and plot that real quick here. 4. I didn't draw that the best. I can actually redraw this here. Now that I have the midpoint, and maybe I should do that before I draw the perpendicular before I draw the segment. As you can tell, I'm not the most gifted at drawing freehand, but there you go. So there's the midpoint of the line segment right here at negative 4, negative 5. Now, we found where it's going to bisect the line. Now, this is also where slope of the line comes into play. What is true about the perpendicular bisector? It's perpendicular to the line at its midpoint, right? So let's find the slope of the actual line first. So the slope of the original line is your y2 of negative 10 minus your y1 of 0 all over your x2, which is negative 8, minus your x1 of 0, which would give you negative 10 over negative 8, meaning the negatives cancel out. This could simplify into 5/4. So the slope of this line segment is going to be 5/4. Now, what is true for a perpendicular line? If we're to find the slope of a line perpendicular to this, what is true? The slope has to be the negative reciprocal for it to be the perpendicular bisector. So the negative reciprocal 5/4, I'm going to call this m sub perpendicular to denote the perpendicular line. That slope would have to be negative 4/5, right? Now for the final part, we got to find the equation of the line. That's going to be then, if you remember, y minus y1 equals m times x minus x sub 1. That's your point slope form. So now take your point slope form where the midpoint of the line is, which is negative 4, negative 5. So you would take y minus negative 5, which is actually y plus 5, set it equal to your slope of negative 4/5 times x minus your negative 4, which would actually be x plus 4. So there's a start for that. I think we can go ahead here now and erase some of this so we don't run out of room to work. We know the slope's -4/5. I just gave the point slope form of an equation. So here's what we have so far. Y plus 5 equals -4/5 times x plus 4. Well, this would simplify then into y plus 5 equals -4/5 x minus 16/5, which then means for the final form we want it in slope intercept. This would be -4/5 x minus 41/5. So here is the equation of the perpendicular bisector to this line. It's going to be -4/5 x minus 41/5. That would be the answer. And I got a couple more examples here. I know it can get a bit messy, but I got two more, then we're done with the lesson. All right, we have 0, -6, so let's start there. 0, -6, we're going to plot that point. And then we have also -4, 9. So we need to find the perpendicular bisector of the segment joint of the line segment that joins those 2 points. So here's -4, 9. Here is going to be 0, -6. All right. So the perpendicular bisector means it's perpendicular to this line segment at its midpoint. So let's go ahead here, find the midpoint. Let's start there. So the midpoint is going to be the x1 of 0 plus your x2 of -4, which in this case would be -4 divided by 2. Then your y1 of -6 plus your y2 of 9, all that divided by 2, which would have to mean then that you would get -4 over 2 for your x, 3 over 2 for your y, giving you your midpoint to be -2, 3/2, or -2, 1.5. That would be the midpoint of this line segment. So why don't I go ahead and plot that? So there's the midpoint of that line segment. That's where the perpendicular bisector is going to be. I'm going to draw this the best I can, all right? So, whoa. Whoa. Yeah, that looks pseudo-like it. Okay, there we go. Right there's the perpendicular bisector. Or, I mean, that's where it's going to be. Now, we found the midpoint. That means next we need to find the slope of the line since we found the midpoint. So find the slope between -4, 9 and 0, -6 of that entire line segment. So take your y2 of 9 minus your y1 of -6. So this would actually be 9 plus 6 all over x2, which is -4, minus x1, which is 0. So this would become 15 over -4, which gives you a slope of -15/4. So the slope of this original line segment is negative 15/4, which means for the perpendicular bisector going through the center of this segment here, the midpoint, the perpendicular slope has to be the negative reciprocal of negative 15/4, which would be positive 4/15. So now we found the slope of the line, and then, so in other words then, your perpendicular bisector, probably not the best drawing, it's going to do something like this right at the midpoint. There's your perpendicular bisector roughly. Now, let's find the equation of that line. So y minus your y1, which is your midpoint, of 3/2. So y minus 3/2 would equal that 4/15, that slope, times your x minus -2, that'd be +2. So this means y minus 3/2 equals 4/15 x plus 8/15. So in the end, you're going to have y equals 4/15 x plus, what is 8/15 plus 3/2? Well, let's see. So that would be 16/30 plus 45/30. So that'd be 51/30. Wow. That's pretty messy. So the equation of the perpendicular bisector ends up being y equals 4/15 x plus 51/30. So that gets pretty messy. That would be the equation of this line right here, in the green. I got just one more, then we're done. Alright, what's the last one look like? Alright, we got the points 3, -7, so let's go ahead and plot that. Alright, there's 3, -7. And then -3, +1. All right. So we need to find, so there's your -3, 1 right here. There is 3, -7. So we need to find the equation of the perpendicular bisector going through the line segment that joins these 2 points. So first find, since it's the bisector, find the midpoint of these 2 points. So the midpoint is going to be your x1 of 3 plus your x2 of -3. So that'd be 3 minus 3 over 2. And then you'll end up taking your y1 of -7 plus your y2 of 1, all that divided by 2, which would end up giving you 0 over 2, -6 over 2, which has to mean then that your midpoint is going to end up being 0, -3. So the midpoint of this line segment is actually going to occur at 0, -3, which would be right there. So there's your line segment there that we got to find the equation of the perpendicular bisector to. So that means your perpendicular bisector should look something approximately like that if you're graphing it. in the brown there. That would approximately be the equation of the line we're trying to find for the perpendicular bisector. Now, we found the coordinates of the midpoint, which will help us in the equation. Now let's find the slope of the line segment from -3, 1 to 3, -7. So the slope equals your y2 of 1 minus your y1 of -7. So this would actually be 1 plus 7 over your x2 of -3 minus your x1 of 3, which would give you 8 over -6, which would end up being -4/3. So the slope of the original line from -3, 1 to 3, -7, that slope is -4/3. But we want to find the slope of the line perpendicular to that, which means it's going to have a negative reciprocal slope of +3/4. So now that we know the coordinates of the midpoint and the slope of the line perpendicular to the original, we can go ahead and find the equation of the perpendicular bisector. So take your y minus the y coordinate of the midpoint. Y minus -3 would actually turn into y plus 3 equals 3/4 times x minus x1 of 0. This won't be bad at all. This would literally just be y equals 3/4 x minus 3. That would be the equation of the perpendicular bisector to the line segment that joins these 2 points. So that is it for this lesson. Next lesson, we're going to start conic sections. We're going to do a 2-part lesson on parabolas. So we're going to go deeper into parabolas than what you've seen so far. They're actually a type of conic section. So I hope everyone has a great day. Take care.